All right, let's get into it. Today, we're going to pull back the curtain on a real GCSE chemistry paper and basically crack the code of what the examiners actually want to see. We're going to take one question and break it down mark by mark using the official mark scheme. Let's do this. Getting those top marks isn't just about knowing your stuff. It's about how you present that knowledge. It's kind of like a game, and today, we're going to learn the rules so you can play to win. So, we'll be working through question 01 from an AQA higher tier paper. It's great because it covers a bit of everything: polymers, recycling, even some chemical tests. Think of it as our little case study for nailing that exam technique. You ready? Okay, first up, we're diving into a question on addition polymers. This is such a classic topic, right? It's all about testing if you can work backwards from a big polymer to figure out the small monomer it came from. Here is the exact wording for question 01.1. It's worth a solid 2 marks, and it's asking you to draw the displayed structural formula of butene. And the helpful bit is they give you the polymer, polybutene, to start with. So on the left, that's the repeating unit of our polymer, polybutene. See that single carbon-carbon bond holding the chain together? Our job is to fill in the structure on the right. To do that, we've got to think: what happens during addition polymerization, and more importantly, how do we reverse it? And boom, there's our answer. To go from the polymer back to the monomer, you have to break that single bond linking the units, and then put that carbon-carbon double bond back in. That double bond right there is the absolute key. It's the mark-winning feature they're looking for. So let's break down where those 2 marks come from. You get the first mark just for drawing the C equals C double bond. Simple as that. The second mark is for getting all the other groups in the right place, the 2 hydrogens and the 2 methyl or CH3 groups. But look, pay really close attention to that examiner's note at the bottom. Do not accept extra bonds. This is so important. In these exams, you have to be precise. All right, next up, the question switches gears. We're moving from pure chemistry to a real-world application: recycling and sustainability. We've just figured out the structure of polybutene plastic, and now we're going to see why that actually matters when you're recycling the copper wire it's wrapped around. So the next question, just for 1 mark, asks for a pretty practical reason. Why do you have to get that plastic insulation off the copper wire before you recycle it? I mean, why not just chuck it all in the furnace together? Well, the mark scheme is actually pretty generous here. Any one of these will get you the point. You could talk about the copper getting contaminated, or the fact the plastic would just burn and maybe release toxic fumes. Or you could just state the obvious: they're 2 different materials recycled in 2 different ways. Any of those works. Okay, this next one's worth 2 marks, and that's a huge clue, right? It asks you to describe the process of recycling the copper itself. When you see 2 marks, you should immediately be thinking, okay, they want at least 2 distinct steps from me. And yep, here are the 2 steps. First mark is for saying the copper is heated until it melts. Obvious, maybe, but you'll have to write it down. The second mark is for explaining that it's then recast or reformed into pipes. The mark scheme also accepts reshaped or molded. You absolutely need both of those points for the full 2 marks. And we're back to sustainability. This is such a common type of question, you should almost expect it. You've got to give 2 clear reasons why recycling is better for the planet than digging up new copper ore. Here are the answers they're looking for, straight from the mark scheme. Just pick any 2 of these. You could say recycling uses less energy, it conserves a finite resource, the copper ore itself, it produces less waste, or you could get specific and say it reduces the need for landfills. Now, here's a pro tip. Notice the examiner's guidance. They say to ignore references to cost. This is a classic trap. They want science and environmental reasons, not economic ones. Okay, for the final part of question 1, we're switching gears again. This time, it's all about analytical chemistry. The question is, how do we actually test for the ions in a solution of copper sulfate? The test for copper ions is another 2 marker, so it needs 2 specific pieces of information. First, what solution do you add? That's sodium hydroxide solution, and yep, writing the formula NaO is totally fine. Second, what's the result you'd actually see? That would be a blue precipitate. The mark scheme also says blue solid is okay. You need both the chemical and the result for the full 2 marks. And now let's do the test for sulfate ions. Again, it's a 2-part answer. For that first mark, you need to say that you add acidified barium chloride solution, and BaCl2 is fine too. That little word acidified is important, by the way. It's to get rid of any other pesky ions that might interfere with the test. And the result? A white precipitate, or a white solid. Simple as that, but you just have to know it. So let's just step back for a second and look at what that one question really tested. It wasn't just about one little topic, was it? It was actually a journey across a huge chunk of the chemistry syllabus. I mean, this table just lays it out perfectly. A single question managed to connect polymer structures to environmental science, then to industrial processes, and finally to analytical tests. Being able to see how all these things link together, that's when you're really starting to master chemistry. So, what's the ultimate takeaway here? The best answers, the ones that get the top marks, aren't just correct. They're precise. They use the specific keywords and phrasing that the mark scheme is looking for. By understanding how you're being marked, you're not just learning chemistry, you're learning to speak the examiner's language. And honestly, that is the secret to cracking the code.